If you have ever flown round trip, long distance away, you have likely experienced this application problem in real life. What happens when we fly is that in one direction we might be flying with the winds and in the other direction flying against the wind. If it's a long enough distance, then there are other factors such as the Earth's rotation that also affect the flight time. But let's look at this specific problem. Charles flies his plane 416 miles with the wind in the same amount of time as it takes him to fly 320 miles against the wind. Notice the question. Find the speed of the wind if Charles's speed in still air is 230 miles per hour. Again, make note of the question. Find the speed of the wind. So if the problem-solving steps that we have are, number one, understand the problem. So to understand this problem, we want to understand what the different variables are, and we want to understand what the question is asking. Next, we would devise a plan, and after we devise a plan, we would go ahead and solve our problem or work out our plan, and then check the answer. But in this first part, understanding the problem, I'm going to use this handy distance equals rate times time chart. And we know that what we're trying to find is the speed of the wind. So I'm going to start out right here with defining that variable. Let's let W represent the wind speed. We can now use that W, that variable, to put our information together in a chart. Charles flies his plane 416 miles with the wind, the same amount of time as 320 miles against the wind. Now his rate, here's what the problem doesn't tell us, what we have to gather from the problem. We know that the speed of Charles' aircraft in still air is 230 miles an hour. So what that tells me is that if he's flying with the wind, this is the wind pushing him. The wind is pushing the plane. So we've got the flight of the airplane plus, the speed of the airplane plus the speed of the wind working together. So we have a rate of 230 plus W. When we're going against the wind is pulling us back. So we're going slower. We've got the flight of the aircraft, or the speed of the aircraft, 230 miles per hour, minus whatever the speed of the wind is, because that wind is taking away from our aircraft's speed. Now we just have to set up our distance equals rate times time problem. And if we want to solve for time, we could do that and get that if distance equals rate times time, then time is going to equal distance divided by rate. So the time with wind is going to be 416 divided by the rate. And the time against the wind is going to be 320 divided by the rate. And do you see this really important piece of information in the same amount of time? So that's our equation. Our equation is that the time with the wind is going to be equivalent to the time against the wind. So let's set up our equation. (416 over 230 plus W) is equivalent to 320 over 230 minus W. Now I have a proportion, which is a special type of rational equation where we have two fractions equal to each other. And you may recall that the process for solving proportion, sorry, my pen isn't working really well, is to use cross multiplication. So we multiply across 416 times 230 minus W is equivalent to 320 times 230 plus W. Now we just have a simple linear equation. We're going to distribute the 416, distribute the 320, and solve for W. I'm going to pull out a calculator here, and if I do 416 times 230, I'm going to get 95,680. And then distribute the 416 to the W. 230 times 320. This gives me 73,600. Solving for W, I'm going to put the W's together. So I'll subtract 73,600 from both sides to get 22,080. Add 416 W to both sides to get 736 W. And now if I divide both sides by 736, I get that W equals 30. And that's it, other than answering the question, because the question asks us to find the speed of the wind. Oh, actually, that is the answer. That's all we needed. I thought it was going to ask us the rate with and against the wind. But we could end our problem here by writing our therefore statement. Therefore, wind speed is 30 miles per hour. And that concludes the distance equals rate times time when we're going with and against the wind. Now let me give you some hints about this type of problem and how else you would use this. You might be riding in a canoe or other boat with the current and against the current. It's the same thing except we change that to current. If I wanted to really go all out and make a video that made really fun time with this type of problem, I'll tell you what I always think of is those people movers at the airport. If you have children traveling with you, then you are very likely to have had a child ask you, "May I run backwards on this people mover?" And of course, I'm going to tell my children no, because there will be someone else coming the wrong direction and cause a collision. But if you can picture walking with the people mover, so that's where the people mover is helping you move along, so we're with the wind, or walking opposite direction on the people mover, so walking against the direction of the people mover. It'd be an interesting problem if we could go to the airport, determine the precise miles per hour of that people mover, and then determine how fast would that child need to run in order to make it to the end of that people mover. But let's save that for another time. And I hope that you are encouraged with this type of problem, that you can do this problem. You just need the right method. You just need to put the information together in a chart, and you can do this.